Hey guys, good afternoon. Thank you so much for joining the session. Today we are going to discuss about complete details on Python OOPS, like object-oriented programming. So I'm going to clearly tell you that, okay, so from the basics to little advanced, and we are going to experience all the concepts with the practice sessions. Okay, not just like only theory. We are going to look into the all concepts practically. We are going to execute the code and we'll have a look into it. So let me share my screen, guys, then we can talk. So I'm going to share my screen. So any questions you have, you can ping me on the chat and I will answer your questions. Not an issue. This is going to be more than 2 hour session. So hopefully we are going to cover all the concepts. Okay. So Python oops. Okay. So let me close everything in my system. So I'm going to start this session in shortly. We'll wait for maximum 1 minute because people are getting started now joining. We'll wait for maximum 1 minute. Okay. Thank you everyone again joining the session. So we are going to discuss about Python object-oriented programming concepts in detail. So I will show you the content with some screens, and also we are going to execute the code in the Visual Studio Code. Okay. So we can also use the PyCharm. There are so many tools are there, but I'm going to use the Visual Studio Code as part of this program. And we can also use the PyCharm. So if possible, I will try to use the PyCharm and Spider at the end of the sessions. I will show you how to write the same code in the different tools. Okay. So let's get started. The first concept of Python object-oriented programming is what is object-oriented programming? Why it is so important, right? Just for your information, guys, object-oriented programming is it's kind of a programming style. So we can use these concepts into the various programming languages like Java, C++, Smalltalk, Ada, .NET. There are many languages we use this one. And Python is also supports this object-oriented programming, but there are few concepts it doesn't support. I will talk about that, what are those. And we are going to see that in detail, how we can look at that different types of the programming concepts. Okay. The first thing is, as part of this object-oriented programming, we are going to look into the what is a class, what is an object, what is method, what is inheritance, encapsulation, abstraction, and polymorphism. So there is a totally 4 important concepts generally we are talk here, that is encapsulation, abstraction, and polymorphism. First, initially we look at what is a class, what is an object, what is a method, how to create in Python. We are going to look into that. So first, before that, so as I told you, this is one of the programming style. It's one of the design pattern, we can say, in other words, to apply into this Python coding. Okay. So why I need to use this object-oriented programming in Python? Generally, right, when you're developing a project, we basically use the real-world entities. For example, you take bank projects. So in banking applications, we have the bank customers, and there is a bank branches, and there are a lot of things, right? Savings account and current account. There are different types of things out there. So when you are building such kind of projects, definitely we have to use these kind of object-oriented programming languages. It makes the development very easier, and we always simulates this kind of projects into the real-world entity, right? So Python is a general purpose language. So how we can say it is general purpose language? There is a 2 reasons. We use Python only for scripting, In the sense, for example, I can use only functional based programming. Sometimes I can use object oriented programming. Python is the only language, okay, it can allow you to write both function based language and as well as the object oriented programming also. So we can use, you can use the oops concepts, you can use the only functions also, it is possible. Now let's get into the topic. So first, most important when you are going to start with this oops concepts, the main terminology is the class, object, and reference. The class is nothing but a blueprint of the. It's basically like constructing the object. It defines all the properties and object. So instead of talking these definitions, let's go to the programming. We'll understand clearly. I will come back to the again these concepts and I will show you how it basically works. Now I'm going to create a new folder here. So let me create new folder. Then we can talk about these definitions and all one by one. So I'm creating the new folder in my local. So using that folder name called like Python, oops, object oriented programming, just create it. I'm just going to open it. Okay. So in this, I will start writing the one by one. So each concept I will create different files and we can execute. The first one is the class demo.py. So in Python, generally we use to create the classes, objects, methods. There's some terminology is there, but I will tell you all the terminology. You just follow me, okay? So in Python, when you are going to create a class, we are going to use the keyword name is called class. So if you are going to start a class, you have to use the keyword name called class. For example, you can use the class name is called the person, right? I can write this class name with this parentheses and without parentheses, something like this. Let's go with the first notation is without parentheses. Class is the keyword, space, and any class name. So I'm writing here the syntax. You just remember here, the class is the keyword and the class name, any name you can take. But always I recommend you to go for the class name uppercase letters. So this is always, this is the naming conventions. You can write lower cases also. Better always you proceed with the uppercase letters because that is actually we follow the naming conventions or the standards. Okay. Now this is the class. What I can do this when I have the class. So you can, in the class, I can use the constructors. I can put the some instance methods. I can create some static methods, and there are different things will be there. So when you write a function inside this, okay, for example, I will write this function. The person basically speak. Okay, I'm writing here the speak and the self and colon, and we can give this some pass, or you can write from print statement. So print in brackets, you can say I'm able to speak, something like this, okay? Or I can speak, simple words. So this one, right? So what is it basically? You have a class, inside the class, there is a Python function. This is basically a Python function, right? We use the keyword called def for the function and the function name, and the first parameter is the self, and internally we use any logic you can write, okay, whether it is a print statement or any logic. So this speak and this is a print statement, okay? So this is how we define the class and one function. This function we can call it as a method in the object oriented programming. In general, it is a function. The functions in classes, okay, call it as, so basically we are calling it as the methods, okay, methods. So right now this name is speak is actually a method, and when you're using first parameter is always self. But to access, this is the class, right? I want to access this method. How can I access, guys, this method? We have to use an object. So remember, guys, this is the class. Inside the class, I have something called a method. This method should be accessed, right? We need to access this method. For that, we need to create an object. So creation of object. So without object, we can't access the data or whatever it is there in the class. The class is the enclosed, what I can say, the blueprint of an object. So if you want to access this class data, we need to create an object. So creating an object. So creation of object. So how to create an object? So to create an object, we need to follow the syntax. Syntax is like object name. Actually, it is not an object. It is object name reference. Okay, or we can say object reference. Generally, we don't use the object name here. We actually use the object reference and we use the name called person, right? Or we can say in this case, it is a person. Generally, I can say it is a class name and we can close the parenthesis. So what I mean to say that if you want to create an object, we have to follow this syntax. Object reference is equal to class name, after that parenthesis. This is called the object creation. So in our example, so in this code, object reference, I can take anything here. Okay. For example, I will take the P1. P1 is the object reference equal to, then I will use the person. The person is nothing but a class. Okay. This class, when I'm using this parenthesis, this is called it as a constructor. Basically, when you write class name after this spelling mistake here, class name, this is a constructor. So without constructor, we can't create an object. So I will explain you that what is a constructor, what are the types of the constructor, how to create and all. So I'm just giving a simple code here, then we'll debug each and everything in detail. Right now we have a class here. The class contains one method. I'm creating an object here. By using this object, I can able to call this the speak method. So what I will do, right, by using this object reference, I'm going to use the speak. Okay, I'm going to call this speak method. Now, if I go and execute this code, we'll get the output is I can speak. So the only way is like to access this method is to create an object reference, and after that I can able to access it. So let me show you. So this is not the one. Let me show you here. Okay. You look at this, guys. This is one of the structure I am showing it you on the screen. So basically, the person is your imported class. So inside that, we are actually keeping the person instance. So that's called the P1, right? In this diagram, it's showing that where the P1 is going to be stored. So P1 is the reference, but actually object is created in the memory. So object is created in the memory. Okay, I will explain you that. Okay, one by one, we'll get the clarity. Now, this P1 is equal to person. Next P1 dot speak. Now I'm executing code. I got this one. What if I'm going to use one more function here? Def. Okay, walk. Inside this, I will put the self keyword and print of. Then you can write I can walk. Okay. So this is another instance method. If you want to access this method also, we can write p1 dot and we can write the walk. So p1 dot speak and p1 dot walk. So when I'm going to execute this code, I'll get both the outputs. I can speak, I can walk, right? It's as simple as. Even tomorrow you have one more method you can call by using this one. Right now, this is the person one. Can I create one more object? Yes. So to create one more object, you can use the P2 reference and you can say that person constructor and P2 dot speak and P2 dot walk. So like that, I can create n number of objects, guys. This is the person one object. This is the person two object reference. Like that, I can create n number of object references here. You can see our P1 is P1 dot speak and P2 P1 dot walk and P2 dot speak and P2 dot walk. All this data is there. Okay. So this something like you can create a number of objects. So this is the person is the blueprint. So n number of persons can access this one, not just one person. Okay. Now I'm going to talk about, I'm going to show you the slide now. What is the class? The class, it is a blueprint to the construct the objects. It defines all the properties and objects. And object is nothing but the physical instance of the class. So object is basically like it is a memory storage. So we can say that we can use we can actually it is storing the memory. Okay, we are storing in the physical memory, and the reference also there. Okay, and the reference is nothing but object reference only. So in this slide, we are saying that it is the blueprint to construct the objects. It defines all the properties. So you can see here the properties, attributes, variables, the actions and behaviors and methods. So what I mean to say that every class can contains these properties and actions. The another name of the property is the variables. Another name of the actions is the methods. So what class contains, guys? Class contains the variables and methods. Okay. So like this, now I'm going to create now some more code, then you will understand much better. Okay. So I'm going to create another class now. So this is time I will explain the constructor. Okay. So constructor demo dot py. Okay. So this time I'm going to create a constructor. This time I will take the different example. Okay. So this time the class student. Okay. This is the class which I am taking up. And inside C, when you are creating the class, you can keep this parenthesis also. You can see the previous example. I'm not giving the parenthesis. So what I mean to say that the parenthesis is giving or not giving, it is an optional. So you can write parenthesis here or without parenthesis also. Just one point you remember, guys, if you are providing or not providing, in this parenthesis, always object will be there. Okay, so this I will explain you into the inheritance concept. What is this parenthesis? What is this object? We can talk. We can discuss this one into the inheritance concepts. Currently, we'll move on to this one. We can see this class student. Let me write. Okay, this class student of object is also similar to the class student without object, and also the class student pass. All these syntaxes are correct only. So if I'm going to write this one without parenthesis, this is correct. So what I mean to say that this code is also similar to this code. This code also similar to this code. So in Python, we can define the class in the three ways. So you can see this class name and object, and class, just class name and parenthesis, and class and class name only. So you mean to say, what I mean to say that there is only, we are actually using the three ways to define a class here. So any code you write, it works. So anything you write, it works basically. Okay, moving to the constructor example now. So I'm going to create a constructor here. So in Python, constructor is always using with the init function, or we can say it is an init method. So whenever you are using a method or a function inside this class, we always use the underscore underscore init underscore underscore. This is called it as a constructor. So if you can ask me, can I write this constructor with other names? No, you should not write this constructor with other name. This is a fixed function name, or we can say it is a fixed method name. When you are defining a constructor, we always write by using this underscore underscore init underscore underscore. Now, inside this, for example, I'm going to write one print statement saying that this is class constructor, or this is the any name you can write. This is a constructor. Okay. So this is a constructor. Let me increase the font size, guys. Maybe if it is very clear to you. So this is the class constructor. Right now, what I'm going to do, right? I will create one more method here. Okay, student, right? Student marks, we can say, are like most student marks average. We can write here. Okay, so inside this, you can just keep the self keyword, and inside this, we can write a print statement. The print of say that the marks. Okay, total marks is equal to something like this. I'm just giving the some dummy value here. Say that 45. Okay, so I'm just giving this some dummy value. Now this is a student, what I will do, right? I will create an object for this student. For example, first student name is assume that Ajay. Ajay is the student. Okay, I'm going to create an object here. Ajay is the student. I will say that student. So I will just create an object for the student. Next time I will create another student is Akbar. So what I will do, right? So this is Akbar is another student. So I will create another student here. Okay. So last student name is the John. I'll create one more student here, John. So every student have the different marks average, right? I can create it like this. So Ajay student, Akbar student, John student. So this is how we can actually create it. So student here, it is actually only the blueprint, but every time we'll create a different object for to access this information, right? So what I'm going to do, right? Now I'm going to execute this code, okay, without calling this function. Without calling this method, I'm going to execute the code. So what I will do, right? I'm going to execute this. Whenever I created an object, automatically this constructor is going to be called. If you look at the code here, output, whenever I created an object reference, you can see here an object is created. Line number 11, I created an object. Line number 12 also I created an object. Line number 3 also I created an object reference. So whenever I am creating an object, this constructor is being, I mean, this is actually calling this constructor. Okay, so what I'm going to do, right? So let me put this one. So this is the class. Inside this class, I'm going to write this is the constructor. Okay, so I can say that this is a constructor and this is an instance method. Let me write to understand better way. So instance method. Okay, and this one, these are all the objects. Okay, so I created the three objects. Basically, Ajay, Akbar, and John, these are all the student names. We can say that object references. Okay, so I created, actually I'm accessing these three objects by using the object references, right? So we have here Ajay, Akbar, John. So same Ajay I can use to access this data. So I can use the marks average. So marks average. So next one is the Akbar and dot marks average. So like that, I can call this information. Now, if I'm going to execute this, same data will be produced here. Total marks is 45. Total marks is 45 like this. But we can send the different data also. Remember, as simple as this is the constructor is going to be called whenever you're creating an object. So Ajay is equal to student and constructor will call. So let me write a flow here, then you understand in simple way. So what I will do, right? Okay, so I'm going to take the diagram and explain to you. So yeah, so clear. So let me take a small diagram here to explain in better way. Yeah, so first, whenever you get this student, so you are actually calling, you are creating a student here. So when I say that this student is going to be called immediately this constructor, right? When I created one more student, this constructor, this is also being called this constructor. When I created one more student, this is also being called this constructor. So this line of code, line number 13 and 14 and 15, these lines automatically we are creating the constructors here. So we have your marks average, the total marks 45, and student. So like that, we are able to create a constructor. We are able to call the constructor, right? So just remember, guys, we are going to use this one as a lot, and we'll get so much of information in shortly. Just remember that one, but I will talk about this one in shortly in details. Okay. So moving to the actual concept. Okay. So what I will do, right? I will add one more variable, one more name here. So for example, I will pass the name, right? So you can see here the Ajay is actually first student. I will change these names to the S1, and this is the S2, and this is the S3. Okay, and this one is the similar like this S1, and this one is the S2. So what I will do, right? Here I will change. I am keeping here first parameter is the name. Not only the name, I can pass the age, I can pass the city, all this information I can pass, right? So in similarly, when you are adding the extra fields to this constructor, so what we can do, right? We can execute the code now. Okay. So what I will do, right? So clear all this. So what I'm going to do, right? I'm going to execute this now. Right now, this the name, age, city are there. We need to pass the same name, age, city here also. For example, I'm passing the name here, Ajay, and age is, for example, 14 years, and the city is, for example, it is the Delhi. And here I see here in the Ajay, so one more name I'm going to pass here, Akbar, and it is another place. He is actually like 15. Again, the place is, for example, Mumbai. Okay. So another name is like John. I'll pass the John information. Now the here age is, for example, 12, and I will pass the place name is, for example, this one is the Bangalore. Okay, so I can pass the different details here. For student Ajay, information is different. For Akbar, information is different. John, information is different, right? So I don't want to execute this function. Now I'm going to execute this code. You will see that this class is constructor is called 3 times, but I want to print these details here. If you want to print this name age, can I use this name here directly, guys? Can I use this name? If I'm going to execute this code, you can see this class is constructor is called first time is Ajay, second call is Akbar, and third call is John. But if I want to use the same name here, I want to use this name here in this mocks average. So what we can do, right? It's very simple, guys. So this name, instead of writing this way, we are going to use the self keyword here, self dot name equal to here, and we can say that name. So what I will do, right, this name I am assigning to this self dot name. So this is nothing but instance variable. Okay, so I will talk about this and all very clearly. We'll just go through it. So self dot name is the instance variable, and also self dot age is equal to age, and this is also instance variable. Okay, and also like I'm creating the self dot city. This is also instance variable. Otherwise, see, the name is actually what you know. This one is the local variable. This local variable I am assigning to the instance variable. So to understand in correct terminology, let me write it here. So self dot name is the instance variable. We are using this one to the variable. So we can say it is the parameter variable, param variable or parameter variable. So okay, same logic will applicable to this one also. Okay, so self dot age, even self dot city. So this is the instance variable and equal to the parameter variable. These instance variable I can access here also. For example, print of the student name is, and we can access this information yourself dot and name. So how we can access and all? It's because of self is nothing but the current object. I will talk about this. I will explain to this what is the self, why we need to use the self. You'll get an idea right now. So what I'm using it, this self dot name is equal to name, self dot age is equal to age, self dot city is equal to city. Now, if I want to access this name, I can use this self dot name. So let me go and execute this code, then you understand very clearly. Now, what I will do, right, this student one object I'm going to use and call this function. What is the function name is marks average. So you call this marks average and you can leave it. Go now, you can go and execute the code. You can see this class is called, this class constructor is called 3 times for the 3 objects, and we got the output is the student name is the Ajay, and this total marks is the 45 because you call the S1 only. You are call this data by using the S1 only. Okay, so S1 dot marks average. So just remember, guys, in the constructor we basically use the self dot name. That's something is called the instance variables. All instance variables can be defined inside the this one. Now let's go and understand the what is the instance variable and what is the self keyword. I'm going to explain now. So let's go with another example here. Self keyword. Okay, self keyword demo. So I'm just going to write here .py. So what we can do, right? I'm going to explain about the self. What is the self? What is an importance of the self? Self. So basically, in this Python object-oriented programming, self is nothing but this keyword. Okay, in Java we have the this. So basically, the people who comes from the Java background, they can see this self in their Java programming is that this keyword. But if you look at this in this code, we actually in Python we use the self for the current object. So we can say it is a current object. So I will create a class now. The class, so next time this is the A. I will keep it this one. So here def, and I will create constructor. Constructor name is always init. So we have to give like this only. So init is the predefined method. We should not change any name here. We have to write same method only when you are writing a constructor. So you can write here self keyword. Okay, so you can write self keyword here. That's where it works, guys. I am just writing the self keyword, and see, I will explain you this one. So I'm going to put the pass. Okay, now I'm going to create an object for this. Just create an object. It's enough. Okay, if you write simple print statement, if you can write here. Okay, let me write here the print of say that this is self constructor or something like this. Now if I'm going to execute this code, you will get the output is like this self constructor, this self cons. Okay, this is the output. Basically you get it. Okay, this self cons. So what I'm going to do, guys, when you are using this constructor, and I will change this self keyword to the delf. Now I'm going to execute this code. This works. See, the point I'm going to tell you, self is the reserved keyword. Okay, but in Python, instead of self also we can use another keyword also, mean to say that whatever the parameter you write in the constructor, okay, the first parameter is always self. Okay, you can write your name also. For example, I will write my name here, Raja. So if I'm going to execute this code, no problem. The first parameter, whatever you write, it will be overridden with this self keyword. Okay, so whatever you write with the first parameter, it will be automatically overridden with the self keyword. That is, you have to remember always here, right? And now, so better always use the self keyword, but you can replace with this. The first parameter of the constructor is the self. That's what I want to say. And also, if this self I can access in the instance method also, correct? So this is about the little example on the self. So what I'm going to do, right, I'm going to talk about the variables. There is a different types of variables are there here. So let's talk about the variables. This is where it will get more clarity, guys, how to create different variables, how the variables can be works. So let me go back to the here first presentation, then we'll get an idea. So class contains the variables and methods. We already seen the instance methods, and already we are talked about instance variable, but I will talk in detail in upcoming session. Okay, and first of all, a complete class. The complete class is contains the docstring. I will explain now in shortly what is the docstring. Docstring is always represented by using the triple quotes when you are starting with the class, and after that we can have a constructor. After that we can have a instance method, and we can create an object like this. So your class contains the docstring, constructors, methods, variables, and objects, and reference variables. This is the terminology when you talk about the object-oriented programming. So, like docstring is just like you are representing the what actually your class is meant for it. What is your class? Why you created the class? What is the story behind it? So that's something you write in this docstring. Okay, but constructor. See, one class can contains only one constructor. One class can contains only one constructor. You can't write multiple constructors. So let me go with an example here. So in this case, if you go with the multiple constructors, okay, so anyway you are in the constructor. So for example, you can take the self keyword. I'm going to write two constructors here. Let's see this whether it works or not. Okay, I'm going to take the two constructors with the same name, but this time I will say that constructor 2, this is the constructor 1. I'm going to execute this code. We'll see that how it works. Now I'm going to execute this code. So basically this will be executed the second constructor only. Remember, so it will be overridden. So your class can contains the only one constructor, even though you write multiple constructors. So latest constructor will be overridden. So there is no constructor overloading concept in the Python. There is no constructor overloading in Python, because we are actually using the same method name here, and also Python is the dynamic typed programming language. We don't refer the different data types. See, in Java, if we go different data types, we used to mention it, but in Python we don't mention the data types. So that is one of the reason also we can say that constructor overloading is not possible in the Python. Okay, it is not really needed. Okay, even you can write it, but it is not read it. So latest one will be overwritten. Okay, so coming to this code, so what I mean to say that your class contains the docstring, your class contains the constructor, your class contains the instance method. Okay, so let's deep dive into in details of this. Okay, let's talk about this. Constructor is always you have to write method name is the underscore underscore init underscore underscore, and this method is useful to do any initialization of the object. If you want to create an object, then only we can use. So unlike Java, you cannot define the multiple constructors in Python. This is the point you should remember. And the second thing is self keyword. Self is the reserved keyword in Python. This is always represents the instance of the class. By using the self keyword, we can access the variables, methods, and of the class in Python. And self is always the first parameter, an argument in the instance method, and as well as the in the constructor, right? So self is always the first parameter, guys. Whether you write or not, it will be overridden with the self keyword only. Okay, so moving to the next one, object oriented variables. So basically, in normal function based programming language, we talk about variables is local variable, global variable. But in object oriented programming, there is the different types of the variables are there: instance variable, static variable, local variable. So now I'm going to create a program to differentiate these variables. What is the instance variable, what is the static variable, and what is the local variable? We are going to look into the programming now. So let me go to now. Already I created the variables. Let me close the all other programmings. Then you will understand the differences between the different types of the variables here. This 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 demonstration is really useful, guys, to understand the difference between the variables. So I will take the class and we can use the customer, or we can go for the okay, I'll go for bank. Okay, I will write here bank. So object is the root class. Okay, we can write parent class. So class bank and object. So here what I'm going to do, right, guys, I'm going to create a constructor. So here init and say that okay, self dot self comma, and what is the bank name, what is this, all the information we are going to keep it here. So for example, here the bank name and bank place and all, or instead of giving this, let me change this bank to the customer. That is the best example I can make here. Okay, so here say that customer name and customer account number. Okay, this is the details we can clearly mention it, right? So these two are enough. So customer account number, customer bank. So what I will do, right, inside this, I'll create the print statement, but also we can write, okay, let me write the print statement here. So in this constructor, in constructor, or we can say, okay, this is fine. Here, I will assign these names. So self dot customer name. So this customer name I will assign to the instance variable. So I can use the different name here, or like any name you can change it here. So self dot c name is equal to customer name. Again, self dot c account number. I can change the name also. C account is nothing but customer account. I will assign this customer account number here also, right? So what I'm doing it here, guys, these two are the parameterized variables. I'm creating here is the instance variables. So these are the instance variables, point number one. I can also create class variables. The class variables can be created here. So I'm creating the class variables here. So class, the variables. The class variables defined at the class level. Instance variables defined inside the instance method and as well as the constructor. So here class variable, let me write first class variable. So I'm going to write here the bank name. The bank name is equal to, for example, because this customer is belongs to one bank, I can say that OBS bank. Okay, and the bank headquarters. Okay, or we can say that we can say that HQ headquarters. Okay, or like let me write full name. headquarters is equal to, you can write to, for example, Delhi, right? So bank name is the OBS, headquarters is the Delhi. These two are the class variables. These two are the instance variables. So class variables we define at the class level, instance variables we define at the constructor level. So not only the constructor level, we can also define these instance variable at get customer details. Okay, so get customer details. This is an instance method. When we can say it is an instance method, whenever you write the first parameter is the self, we are calling it as an instance method. So this is the constructor. Okay, so I'm just writing all these things, guys, just for remembering purpose. So this is the constructor. This is the instance method, right? So when we can say instance method, there are different types of the methods are there. But when you use a function, the first parameter is the self keyword. That is something is called it as the instance method. For example, if you want to pass the different terms here, or different parameters also, you can pass ch. Ca is nothing but I can say take it as the customer age. Okay, customer age also I can consider here, or like customer location also. Here I am creating some more variables, customer location. Okay, or like amount. Okay, amount is also fine. So how much amount he is actually using it, that's something we can define it here. Now I'm going to use this print statement, print of, and this customer age is only like applicable to here, but if you want to access that one anywhere in the code, we can use the self dot and ch is equal to the customer age and self dot c amount. So customer amount is equal to and amount. So you can define like this, right? So customer age, customer amount. What I'm going to do right now, guys. So this is also called it as the instance variables. Okay. So instance variables means when you use the self keyword dot variable name and self keyword dot variable names, we can do like this. And one more important thing is instance variables can be created inside the instance method. This instance method, instance variables also can be created inside the constructors. So instance variables can be created either in the constructor, it's in the both the options are available, but we use the always self keyword. Self dot variable name means it is an instance variable. That's like we are creating the instance method and constructors. So if I want to access this self dot c name, I can access here also. For example, I want to print, okay, and say that customer details. So I will use this customer details, and inside this, what I will do, right, print of, so customer name. Okay, so I will use the customer name, and after that, what we can put the name here, self.c name. If you want to access this customer name inside this instance method, I can use the self.c name. And similarly, if you want to access the customer account, we can also give this c self.account here. Okay, so c account. Here I will change this one to the account number. Okay, as simple as. So you can write this way. So customer details, customer name, customer account number, right? So even this details also, if you want to access this ch here also, we can access, guys, because self dot variable name is nothing but instance variable. Instance variables can be accessed in the constructors and as well as the instance method. That's where like we are using it now. Okay, so what I will do right now, I'm going to print other details as well now. So you can look at this customer age. I want to print this one also. So customer age, and we put this self dot to ch. Okay, and also we have something called customer. So what is the next one is the customer amount. So what is the account amount? This is nothing but account amount. So we are using the name called, it is a seal self dot account amount. So I'm just giving this one as well. So this is about constructor. And if I want to access the bank here, so bank details also I can access here. For example, you want to print bank details, bank name. So to access this class variable, this is the class, right? This is the class variables. To access this class variables, we always use the class name. For example, I want to print the bank name here. So what is the class name here? Class name itself is the customer. Okay, customer is the class name. Dot, then we can see here bank name. If you want to access the class variables, basically what we use, right? We use the class name dot bank name. So what I'm going to write here to understand in better way. So class variables can be accessed, okay, can be accessed by using the class name. You can mention like this. The class variables can be accessed by using the class name. So that is what you are looking at here. The customer dot bank name example is this one. So customer is the class name. The bank name is the class variable. That's why I'm able to access it, right? As simple as. So not only this bank name, we can also access the headquarters, right? So what I'm going to say that simply I'm going to add one more print statement here. Just you can add this print statement. Instead of the bank name, I will say that headquarters, and this same headquarters, I will write it here. So bank headquarters basically, right? As simple as. So this is what instance method we created. The above one is the constructor, and these are the class variables. There is one more variable name is called the local variables. If you look at this object-oriented variables, we are talking about instant variables basically. So instance variables we are done. Static variables, see, another name of this class variables is called it as the static variables. So another name of this this class variables are call it as the static variables. So static variables, class variables, both are same only. Okay, class variables, static variables, the terminology is same only, guys. So we are done with the instance variable. I can say it is a class variable. Okay, variables. So instance variable we are done, class variable or static variable we have done. Now we are moving to the local variable. So what I will do, right? I'll create one more method. It's called saying that, for example, customer, what we can say, customer address. Okay, C address. Okay, I'm just going to write here, or like a customer, some other information, how much money recently drawn. Okay, withdraw. Okay, so maybe withdraw some amount that I am going to write it here. Say that self is not required. You can write here self also, it's fine. But again, it is an instance method. Here, what I will write, right? So withdraw amount is withdraw amount equal to, for example, 500 USD or something. This withdraw amount, right? This withdraw amount is actually like a local variable. Without using the self keyword, we can say it is, you can see here, it is a local variable. So withdraw amount is a local variable. If you want to print, you can print. If you want to write some logic or like principal amount or like compound interest, something which you are calculating, you can calculate here. Okay. So what I'm going to do, right, withdraw amount. This is a separate method which I created here. Customer withdraw amount or something like. So what I've done here, there is a totally one constructor, one instance method. Again, this is also instance method. Okay, we have created one more instance method here. So this is another instance method which I have taken basically, right? So in the instance method, we have the local variable. So that's how we created it basically, right? So what I mean to say that we can create a class with variables and methods. Constructor is also one kind of a method, but we are treating with the special case. But whenever you are creating an object, then we can use it. Now, what I will do, right, in this code, I'm creating an object for this. So first of all, customer one is equal to customer, and inside this customer, I will pass this. See, one more important news, guys, here. If I'm going to execute this code, it will throw an exception, because you can look at here very straight away answer is, when you are working on this constructors or classes in your programming, you have to do something. It's saying that two required positional arguments are missing. So if you go back to the code and little bit on top, this constructor is expecting the two arguments. Self is ignored because it is only for the internal purpose. Whenever whichever object you call, the self will say that, okay, this is the customer one object, and self again customer two call, and it will say that customer two object. Again you call, and it says that customer three objects. For every customer, this object is being called, but intentionally here we have to send. So if you are not sending the customer name, customer account number for this constructor, will be a problem, because this constructor you can write without these two, that's called parameters. You can also write with parameters. So constructors are the two types: parameterized constructors and default constructors, right? Default constructors and parameterized constructor. Right now this is the parameterized constructor. So what I need to pass here, I need to pass the data. So what I will do, right, I am passing here. So customer name, which is in the string, I'm going to write here the string here. So string is what? Customer name. For example, let me write yes, the John. And next one is the customer account number that I'm going to write into the 1234. So now if I'm going to execute this code, this issue is gone. Whatever the issue we are facing, that issue is gone, because this customer is the constructor is going to be called. This constructor is expecting these two parameters. Let's move on to the next code. Now, this C1 dot, by using the object reference, I can call these functions, right? So what are the functions? I can call this get customer details. I can also call the get withdraw functions. So let me minimize it. Okay, so you can see there is a instance method. This instance method, both instance method I can call. C1 dot get customer details. I'm calling this method. Now what I will do, right? I will execute this query. You can see this. Okay, it is expecting again. Okay, I'm calling this get customer details. Again, this is expecting the customer age and amount. So these are the parameters we need to pass this method. So what is the age is here? For example, customer age is the 45. The amount which is going to keep it there is like $3,000. Okay. Now I'm going to execute this code perfectly, and but it's saying that customer object has no attribute called self. So what is the point here? Because I've written the self two times here. Okay, so here I've written the self two times. That is the reason we got an exception. But anyway, that is removed now. Now I'm going to execute the code. You can see that we got the output here. Let me close this one again, execute the code, then you see the output. So in constructor, then again, you can see this entire customer details are there here. Bank name, bank headquarters, the customer name again, customer account number, customer age, all these information which are able to produce it, right? And you may think like, okay, fine, Raja, so you're talking about variables, you're able to show this. See, we can access the class variables by using the class name and all, but now I want to access this bank name outside of the class. I want to access this bank name outside of the class. If you want to access, okay, so I'm writing, if you want to access class or static variables, okay, outside of the class. So we need to use the class name only. So what is the class name? Then use class name. Okay, so what is the class name here? The bank, customer is the class name. So customer dot, so I can access the headquarters, and also I can access the bank name. So what I will do, right, I can access this one by using the customer dot bank name. So this is just like a variable name. So print of customer dot bank name. If I'm going to execute this code, I'll get the output is OBS. So what I mean to say that if you want to access the class variables outside of the class, then we can use. So it's very simple, guys. Class name dot and variable. Remember, you can access this variable only here, the one which you represented here, bank name and customers. Now you may think, can I access this customer name outside of the class? Let's go and try now. Now I'm using the print statement, and I'm using this customer dot c name. and now I'm going to print this code. If I'm going to print this, it's saying that customer has no attribute. So we can't access the object variables by using the class. This is not possible, right? So this is not possible. This is incorrect syntax. This is incorrect call or incorrect method call. So we are not supposed to use this one because CNAME is actually a it's kind of a what I can say, it is kind of an instance variable we can't access. Can I access this scene directly by using the object reference? For example, C1 dot, I'm going to use this one, print of C1 dot. Now what I'm going to do, guys, I'm going to call this CNAME. Now we'll print this one, C1 dot CNAME. If I go and print this one, I can access. So very simple, guys. Okay, let me write a statement here. So you need, okay, object, okay, instance variable access. If you want to access the instance variable, if you want to access the instance variable outside of the class, okay, outside of the class, so we can use the direct object name. So object reference name and dot, so then whatever the name, okay, which you can give. So that is nothing but variable name. If the same thing, okay, I'm writing instead of instance variable, in this instance you can change the name static or class. If you want to access the static variable or class variable outside of the class, we don't need to use this object reference, we use the class name. Okay, these are the two things you should remember. So instance variable can be accessed outside of the class by using the object reference. Static and class variables can be accessed outside of the class by using the class name. Okay, these two are the very important things you should remember when you are dealing with the instance variable and class variables. So last variable name is called the local variables. Local variables can be accessed only within the method or within the constructor or within the what I can say that any method, you say that instance method, static method, whatever it is. So basically in Python, when you talk about the object-oriented programming, we have the three types of the variables: instance variable, static variable, another name is called the class variable, and the last one is the local variable. Okay, this is how we can define it. So let me go through this understanding here. Instance variables are always declared with the self keyword. Instance variables can be accessed by using the object reference. Instance variables are the object variables. So multiple copies are created when the multiple objects are being called, and instance variables can be deleted by using the del command. This we'll talk later. Okay, moving to the next one, static variables. The static variables are defined the outside of the constructor and instance method. Static variables can be accessed by the class name only. Static variables are always the class variable. So whenever I say static variable, it's nothing but the class variables. So whenever you write these variables outside of the, see, basically you are defining the outside of the constructor and outside of the instance method. That time these static variables we are going to use it. And one more important thing is the local variables. This you can define anywhere actually, the instance method, constructor, or any other utility method, anything you can take. This local variables can be used, and we are not using the self keyword. Without self keyword only we use these local variables in the methods. So this can be accessed only within the method. Next to the coming to the point, what are the different types of the methods? We understand till now the variables. Now we are going to talk about the methods. There is the three types of the methods: instance method, class method, and static method. We'll see the differences between these three. So instance method is nothing but we are using by object. Class method we use by the class instance, I mean class scope only. Static method is like something we can call it as the utility method in the Python. Static method also we can call it as the utility method. So to make sure that you may little confused with the syntax, I mean some terminology here, I'm going to clear some terminology. So let me write the variables and methods. dot py. Okay, here I'm going to write something which is really useful, guys. I'm just going to write it because we need to understand. See, if it comes to the variables part, okay, we have this. So what I will do, right? Here in this variables, especially here, in this variables are there, and we have the methods. So this is a what, right? We have the variables and methods in Python. So variables, what are the things I spoke? Okay, it's very simple. Local variables and the instance variable, right? So, and last one is the, okay, local variable, instance variable, and the class variable. So what we can say that here, this class variable also call it as the static variable. Okay, so class variable and static method. These three are the different types of the variables. When it comes to the methods, we don't have the local methods here. Okay, we don't have the local methods. We can say utility methods. We can say that utility methods. Okay, another name is called the static methods. So remember, this is a terminology you should remember. And next one is the instance methods. Okay, and the last one is the class methods. Okay, so this is the difference terminology: local variables, instance variables, and class and static variables. The methods are like utility methods and static, and instance is the instance variables and class. So this instance methods basically deals with the objects. Okay, so we actually use the objects. Here also we have this one. Because why I'm talking about this differentiation, because the class and static is the same when you talk about the variables, but the class and static are different when you talk about the methods. Okay, remember, the static is the separate now. The static methods are separate, class methods are separate. When I talk about the class methods are class variables and static variables, both are same. This is what I want to tell you, that differences when you're talking about object oriented programming. All right, so let me go and create a different methods here. So I'm going to create here different methods. So methods dot py. So let me create quickly different methods. One is the instance method and all. So I'll create a class. This time I will take the employee. Okay, so this employee, you can keep it here. Just go and write constructor. So writing here the constructor init. So inside this init, I'm going to give the self and put here and print. This is the, we can say that this is constructor cons, and I'm going to create instance method now. So def, we can say that get employee, or we can say, okay, this is fine now. Get employee details. So this is one constructor, or we can say this is an instance method. Sorry, this is an instance method, guys. So we can put it here. And if you want to create a class method, so I'm going to create a class method here. Class method is, for example, employee education. Okay, for example, employee education. So what we don't use the CLS self here, we use the CLS. CLS is the keyword. If you want to create a class method, we have to use the decorator name called the class method. Okay, so if you want to create a class method, we have to follow this rule. Rule number one is, you can write any object name, but basically it is a CLS. CLS stands for the class. We have to write, and then you put the pass. Okay, this is the class method, guys. If you want to write a static method, write def, and we can say that, okay, we can say that employee, and we can keep some information like it is a utility method. Okay, I'm creating now static method. We can say that employee, employee, but we can say that employee skills. Okay, something like this. I'm going to keep it here. Employee skills. Here I don't use the self, I don't use the CLS. I will keep it as normal. And here the decorator name is, it's very simple. I'll give the decorator name is the static method. Okay, so this is how we need to write. Okay, the first one is the instance method. Here I'm going to write this class contains, you see, guys, first one is the constructor, this one is the constructor, this one is the what I can say, This is the instance method. As we are seeing that the first parameter is the self, and this one is the what I can say that class method. So because as we see that a decorator and as well as the first parameter is the CLS. So we can define it here. And this last one is also call it as this, it is a utility method, but you can say that it is a static method. So static method, and so we can say it is a utility method also. So utility method also. So in Python, generally we have the different types here, different types of the method. So constructor is also method, you know, constructor is also method, instance method, class method, static method. So totally we have the 4 methods. But when you write init method in your code, it is always call it as a constructor. When you use the self keyword, that call it as the instance method. When you use the CLS code, CLS is the parameter, then we can call it as a class method. When you use the nothing, but use the decorator name is called the static method, we call it as the utility method. But now, how can I access this data? Okay, the class method is always accessed. This can be accessed. Okay, so accessed by class name. Okay, this is always accessed by like object name or object reference name. Okay, reference name. So through object only we can access this utility method. Okay, this utility method I can access by the accessed by, we can give the name called class name, and also okay, we can use the object name, object reference name. So what I mean to say that, so these are the 3 important methods, guys. Just remember. So instance method can be accessed by the object reference. Class method can be accessed by the class name, and static method can be accessed by the class name and as well as the object reference. So basically we have the 2 options here. Okay, so we can access by the class name and also object reference. Now what I'm going to do, right, we already see, if you look at this object oriented method, this is these methods only I'm talking about: instance method, class method, and static method. So coming back to here, now I want to define some code here. For example, here I'll go and define the, for example, I can say CLS dot, and here what I mentioned, education, right? So last qualification. Okay, so last qualification, and we can say that it is something like BTech. Okay, I'm going to mention this one. Now what I will do, right, I want to print this data. So we'll say that employee qualification. Okay, so employee qualification, so we can say like this, and comma, and we'll use this entire this information. And one more important thing, guys, for example, in this employee level, if you put any name, for example, employee company name also we can give here. Basically is working for some organization, that company name is equal to, for example, is working for ABC company. Okay, so you can also access this employee company name here also. Okay, for example, okay, so I'm going to print this employee company name, employee so I'm writing employee company name here, CLS dot. We don't need CLS dot, but we can go with the direct name here, class name. So because I can access this one by using the class name, right? I'm using the employee dot. What is the class name here? Employee company name. You can give this name. Okay. So this is the one, last qualification. Now I want to call this method, guys. Can I call this method without object? Can I call this method without an object? Yes, we can call now. So what we can do, right? We will use this employee is the class name. So I will use this employee dot, and we can see this. There is a employee education. So I'm going to call this employee education here. Okay. I'm not using the object. You can see this is not, I'm not using the object. I'm calling the class method by using class name. Okay, I'm not using object basically. So now I'm going to execute this code. If you can go to this one, I got the output is So employee qualification is B.Tech and employee company name is the ABC, right? It's we can easily print that one. So calling the class method by using the class name. Can I access the same thing by using an object? Yes, we can create an object also here. I'm going to create an object here. So how to create an object in Python for a class? We can use here E is equal to employee, and this employee is not, this constructor is not expecting anything. Okay, we don't really need anything. Now I'm going to create this constructor object. So E dot, again I'm calling this one. See, this method I called by using the class name. Now I'm calling with object. So same thing I'm writing here. Calling the, okay, calling the class method by using object now. Okay, this is called object reference name. Okay, so what I mean to say that the first one we call just by using the class name. Second, it's the same thing we are following now. This time we are using an object and calling it. Now I'm going to execute this code. You can see this, I got the same output. The first printable state, first this line number 28, I got the output is BTech and ABC. Again, I am calling this, creating an object and calling that same method. I got the output is the BTech and ABC. So in also in additional, we got this is the constructor, right? And whenever line number 31 is, this is nothing but an object creation, right? This is the object, we are creating an object. So object, so creating an object, right? This one is in Python, how to create an object. So you can use the any object reference name is equal to some class name, something like this. So create an object, okay, like this. Now, what I'm going to do, right, guys, this static method I want to call. How to call this static method? Let me go and write some skills here. Skills like programming skills. So programming equal to, and we can write a list. So far, I am not used the list and all. Here, every time I'm using these strings and everything, we can also use the list. But we can talk advanced OOPS concepts little later. But let's focus on the basics. Basics is very important at this moment. So right now I'm giving these programming skills. I can say that Java, I can put the something called Python, I can put something like different skills I'm going to put here. And databases, you can also write here, or databases. Okay, so these are the local variables, guys. Okay, remember, these are the local variables. I'm just creating the local variables. Of course, this is a list. If anybody don't know, this is the list. I'm also creating the databases. I'm just not creating the tuple. So in this tuple, what I'm going to put that, for example, Oracle is one database, right? And also we have another database is called the MySQL. Okay, and the last one is like Cassandra. So these are the databases. I can write it here, right? I'm done with this. Now I'm going to print. This is a list. This above one is the list. This is the tuple. Okay, so this is the tuple. So what I'm going to do right now, I'm going to print this data, and as usually, so programming and print programming and print databases. Okay, very simple. But I will talk about how to access the other variables inside this also. We'll talk. So this is a static method. I can say that when you are going to say static method means there is no any first parameters here. There is no self, there is no CLS. We use only this decorator. And to call this one, as I already mentioned here, static method or utility method can be accessed by using the class name and object reference. So what I'm going to do, right, I'm going to use the name called, I already we have in the class name. So what I will do, right, same statement I will copy paste here. So here instead of the calling the class method name, this is not class method, it is the static method. By using the, so we can access by using the class name and as well as class name and also with variable object reference. Okay, we can use the object reference here. So what I'm going to do, right, guys, employee is the class name. I will use this employee dot, and I want to call this, okay, basically this employee skills. Employee skills is the static method. I'm going to call this one by using the class name. So employee skills, I'm calling this is the static method. And also I will use the E. E is nothing but an object reference. So E dot and employee skills. So I can call the static method by using the object reference and as well as with the class name. I'm going to clear this text, executing this code again, and you will see the output is. So I'm able to get the output 2 times, right? Because the first output is because of this one. So these two output is for the line number 39, and the last two, these outputs are, it's because in the sense like you are printing this one at the line number 40. Okay, you're printing this data at line number 40. So that's where like we can call these static methods and class methods. Anyway, instance methods you understand in the previous examples, right? Instance method can be accessed by using the only object references. So I'm going to write that one also here just to make sure that. So we are writing here. So calling the instance method. Yeah, I'm writing the calling instance method by using the object reference. Okay, object reference name, and we can write, for example, you have here I'm creating an object, we can call it. Okay, so anyway, you can use the object name, we can call this one. So there is a three methods, guys. There is a three variables and three methods. That's what we are talking about here. So look at this instance method. Let me go to the show you that what is the content here. The instance method is the method defines the inside the class using the self-reference object variables. These methods are being called by the object variable reference. First argument is always self keyword in instance method. In the class method, this method is defined inside the class without using the self-reference object reference variables. These methods are being called by the class name itself. So we are using the class method here. We are defining the method name, and inside that we are saying that class dot variable name, something like this. And also we have the static methods. Static methods can be defined by using the at the rate of static method, and we don't need to mention anything here. And static method is need when accessing through the object, otherwise class name. So we can access in the both three, I mean multiple ways, 2 ways, 3 ways, something like this. So last one, moving to the next one, inner classes. So can I create a class inside the class? We can create it, guys. Let me go to the explaining the class inside the class, then we'll see an example now. So what I'm going to do, right, inner classes. Okay, inner classes dot py. So before going to talk about inner classes, let me finish the docstring. So what is the docstring? What is the important of this one? Docstring dot py. So I'm going to create a docstring dot py. Here, let me create one small thing. Okay, it is a demo class. So you just leave it here and you put here. And I'm going to create something about docstring here. When you're creating the docstring, you have to use the triple quotes. This is defined for demo session. Okay, and like that we can write whatever the data which is basically belongs to this class, and after that you can write a constructor here in it. And generally this is how we write in the real-time projects. We actually define the doc strings. Doc strings are nothing but requirement information, what actually you are doing with this class. You can write multiple lines also, guys, not only one line. You can write multiple lines here. Okay, so text, this is something like this. You can write multiple lines also, we can define it. So after this pass, and this is fine. So like that we can, this is a constructor I define. So for example, you are going to, if you want to call this doc string, so we can say that so demo dot, can I use this underscore underscore doc? Yes, we can call this one by using the class name, the print of, and the class name dot underscore underscore doc. Okay, if I use this command, I can able to print the doc. See, you can see in the output, if you want to print the doc string, we can access by using the class name dot underscore underscore doc underscore underscore. The doc strings are nothing but, okay, it is a descriptive information about your class. Okay, descriptive information about your class we can define in that way basically. Okay, so that's where it works, guys, when you are writing the this one. So demo dot underscore underscore doc, which you are able to print it. Okay, so another terminology, see, this is actually a first line statement. So can I write this statement after the init method? So if I'm going to write here and I'm going to execute this code, you will not get any output. Okay, this is only, you should remember, guys, doc string can be written only at the first statement of the class. It can't be even, see, if you're trying to write at the second statement, it will be allowed. This will be treated as a string. So this is it's nothing but normal string. Okay, this is the normal string. This is normal string. Same thing you write here, first statement of your class, this will be treated as the doc string. That is a differences, right? Okay, so this is the demos. This is defined for the demo session. I am putting it is a doc string, and this is for the just normal string. Okay, just this is the only differences you should know when you are working with the doc strings. Then go and execute this code. This is only printing the doc string. This is not printing. This is treating as a normal string. Okay, understand, right? Doc string is only for the first line of the code inside the class when you are defining it. Okay, so moving to the next part, inner classes. What is the inner class? How we can use it? That's something which is going to be useful now. So what I can say that I'm going to create now. I'm reading actually comments. There is no comments, so that's why. Okay, and now moving to the next one name called the inner class. Inner classes. So how to create a class inside the class? Let me create it, guys. Okay, class. Okay, this is the outer class. I'm creating the outer class here. Outer, and you can keep it here. The class inner, and this is the one you can write. So I'm writing in the both the places constructors here, def, and this is the constructor, and this constructor I am defining with the self keyword. Let me write here and say that print of this is the um, this is outer class constructor, outer class cons. You can define like this, and same constructor I'm going to copy paste inside this inner class. I'm defining it here. This is, we can say that inner class constructor. So outer class constructor, inner class constructor. Here I will take one more method, guys. Def, say that it is a inner show method. I will create some inner show method. It is an instance method. I will write it here and go to the print statement, and you define the, this is the inner show method. So basically what I'm trying to do it here. So how to access the inner class objects, how to call this one, okay. Def, this is the outer show method I'm writing here also. So we can write self keyword and print. There is a print statement, and we can write here, this is the something like this. This is the outer show method. Outer show method. So one constructor and one instance method. And again in inner class, this is basically I'm talking about the class inside class. Can you look at this? This is the inner class. So inner class, this is the inner class, right? So this is the outer class. So this is the outer class. Okay, this is the outer constructor. So outer cons. This one is the inner constructor, right? So inner cons. This is, it's very simple. This is the instance method. So this is inner class inner class instance method. I'm just writing it just for understanding purpose. And this is the same thing on copy paste and writing here. Okay, so this is the, okay. This is the outer class instance method. So we can write in like different ways like this. So now my question is that how to access this method. I want to print inner show method. I want to print inner show method. I want to access this inner show method from the given this notation. So what we can do, if you look at this the presentation here, I mentioned the three ways we can access the object. One is that create an object reference, then you can call the inner class constructor. That is one way. Or we can use the directly inner reference equal to outer dot inner, or we can directly use the single sentence like this, outer dot inner dot instance method. So basically there is the three ways we can call the inner class data. So I will go with the first example, guys, here, outer reference and all this one. So let me take this code, and so So what I will do, right, I will paste it here because you can see I'm creating, or else I'll go with my own way. So you can say that outer, you are creating a constructor here, outer, and that I will say that the O reference are like outer reference. So I will give the full name to avoid confusion. So outer reference is equal to this outer, right? So what I can do, right, this by using this outer reference, I can call the inner class. So I'm saying that this inner class I'm calling. So the first one is calling the outer row. This is nothing but creating an object. Creating an object for outer class. Outer class. So next statement is by using this this object we are creating, right? By using the by using outer class object reference, by using object class reference. So basically I'm accessing the, here I will say that accessing the inner class method by using the outer class. Okay, this is the one. It's a very simple. And right. So accessing the inner class method and by using the outer class object reference. So this time I will say that this is the outer obj. Okay, outer obj. So finally what we can do, right, so outer obj, I will taking that outer obj and will call this dot this inner show method. It's a very simple code, but I'm just writing it here. Outer object dot inner show. Now I'm going to execute this code, guys. Let's see this, what will be the output. So we got the inner show method, right? So like that, we can print the output. So we can call the inner class methods. It's not only this inner show methods, we can also use the anything. But whenever I call this first time, this line number 23, I got the output is this is the outer class constructor. Next time I got the output is this is the inner class constructor, like this. We have the two outputs. One is outer class constructor, another one is the inner class constructor. And finally, we are calling the inner show method. So inner show method is we got the output is like that. What is the inner show method output? So the same thing we are able to print it. It is not only about the instance methods, we can also call the class methods. You guys try and let me know if anyone is struggling or any issues with the, see here I'm using the just like instance method. Why you not go and try with the class method and static method and try? It'll be interesting. But accessing this way. So if you think like these are the 3 lines of the code which is not sufficient to you, there is another ways like you can give directly this name. Okay, so I'll go now, I'll give the same name. So you can give this inner reference, say that inner reference to, and what I will do, right, I will directly access this one. So inner reference to dot, then give the name of this inner show. This is a one single shot, we can finish it off the both. So what I'm do, right, I'm going to execute this code. We got the same output again, right? So if you think like these 3 lines of the code, which is very not straightforward, then we can go for the using this way, outer dot inner. Basically, you are using the outer class constructor dot inner class constructor, and we are creating a reference here. By using this reference, we are calling the inner show method. So this is how it is working basically, right? This is how it is actually working here. Okay, so this is about little inner classes. If you guys think you come across with any ideas, let me know. But inner class is widely using into the frameworks, application development and all. Okay, that's where this is really useful when you are working on it. Okay, so moving to the next concept here in this object-oriented programming. So the next concept is called the garbage collection, which is one of the most important concept, guys. So for example, what is the garbage collection? So the object which is object, if it is not used for more than given time, like no longer to be used in your application, then we can know there is a garbage collector is going to be there in the Python virtual machine, which will be invoked by default to destroy the useless objects. So to work on this garbage collection, we have to use an inbuilt module name called the GC. So which is a Python module called GC. We have to import the GC and do it, right? So basically this garbage collector is like we are using like to delete the unused objects. But anyway, this concept is something like deleting an object. For example, let me go to this. So in this code, if I want to delete an object, you can use the del command. You can use this inner reference. You can delete it also. If I go again, if you are trying to access this inner ref, so or else I will say that's line number 30. Again, I am going to call here and you'll get an exception saying that inner ref is already deleted, or it means it is not defined. Okay, so it is not there in the memory now. This is unbound. It is not bounded with the memory. So that's what you have to remember, guys. So inner reference to dot inner show. So this is deleted from the memory. So it is you are doing it by your manually, but when it comes to the project development, and if your object is not used for a longer time, this object will be deleted automatically. So moving to the next one is polymorphism. And what is the polymorphism, guys? The polymorphism is like, so instead of going all these concepts, so you may little confused. I'll tell you very simple coding way, then you will understand what is the polymorphism, what is inheritance and all. Okay, I'm closing all these things. Let's focus first inheritance concepts. So I'm going with the first inheritance concept. Inheritance is before going to inheritance, there is some relationships are there, has a relationship and is a relationship, and association, and also we have the different terminology here, right? What is the association? Association, which will talks about the relationship between the two objects, right? You take any objects, two objects, and if you want to define association, if you want to define the relationship, we actually call it as an association. Associations basically there is the two types, and we can say that strong association and weak association. The strong association is always called it as a composition, which is like I will tell you an example also. Weak association is nothing but aggregation. So if you take an example of the bank and customer, so the bank, customer and employee, right, which is a strong association. See, the bank is there, it's because of customers. If no customers, there is no bank. Okay, so and also if there is an employees and there is a bank, right? So employee customers are strongly associated with the bank. This is called the composition. This we can another terms we can call it as a strong association. And the branch and customer, so definitely there are some banks without branches also, that could be possible. So we can't say that 100% it is a strongly related. So this time we can say that it is a weakly associated. Okay, so there is a weak association, there is a strong association when you talk about the two different objects. Okay, and comes to this easy relationship and as a relationship. The easy relationship, it is nothing but inheritance, which is unidirectional data. So apple is a fruit, car is a vehicle, the man is a person, or something like that we can define it. Student is also person, right? So these are all talks about the easy relationship. The has a relationship, it talks about the properties. The apple has the shape and tasty, the car has the engine, like TV has the brand name, TV has the resolution, TV has the color, which is all like something we can say that has a relationship, right? So is a relationship is the inheritance, and has a relationship which talks about the properties. Now moving to the inheritance concept, there are various types of the inheritance we have it, but what is the significance of the inheritance? Inheritance is one of the feature. So in object oriented programming, there is a four important topics, guys. One is the inheritance, polymorphism, abstraction, and encapsulation. So these four are very important topics, but currently I am talking about inheritance. So inheritance, which is always talks about the code reusability. If we want to use the same behavior into the different classes, and we can go for the inheritance. The code reusability to the program, because we can use an existing class to create new class. Okay, so instead of creating the multiple classes from the same information, we will use the existing class. Okay, so if you look at on my screen, when you are going to define the inheritance, we need at least two classes. So here we have the class name called the base class and derived class. In another terminology, we can say parent class and child class. In another terminology, we can say that superclass and subclass. These are the terminology, guys. Base class, superclass, and parent, derived class, child class, and subclass. This is the inheritance relationship, the parent-child relationship. It is a parent-child relationship which you are looking at here. Okay, so moving to the next one, what are the types of the inheritance? So inheritance is the single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, hybrid, and cyclic inheritance. You look at this example, guys. There is a, when you talk about the multiple inheritance, I'm not talking about multiple inheritance here, multi-level inheritance. When there is a multi-level inheritance, we have the a base class and derived class. In between there is something is called the intermediate class. So there is a bridge class is there. So the class A and class C, in between there is a class B, something like that. And when you go and talk about the multiple inheritance, this is like two parents with the same child. Okay, one child having the two parents. Okay, A, B are parents and C is the child and C is having the same parents. So something like this. Okay, but multiple inheritance, most of the times we face the issue is the ambiguity problem, diamond access problem. I will talk about what is the ambiguity problem and diamond access problem. And this can be solved by using the method resolution ordering. When you're using this MRO concept in Python, we can solve this issue. Okay, so what is the diamond access problem? What is the ambiguity problem? See, here there is a two parents with the same child, but child is little confused which parent data I need to access, right? This C is confused which parent information I need to access. Is it the parent A or the parent B? This is something called deadlock situation. This is something we can call it as the ambiguity problem. This ambiguity problem is resolved in the Python by using the MRO principles or MRO method resolution ordering. The same thing cannot be possible in the Java. So Java does not support the multiple inheritance, and there are so many reasons, but the main reason is that in the real world, it is not possible the same child can have these different parents. So that is the reason you can call it as the ambiguity problem here, diamond access problem, and we'll say that it is a method resolution ordering now. We can solve that one. So moving to that hybrid inheritance, here there is a class A and class D, but they'll have the different hierarchies here. So a hybrid inheritance means we can say that there is single inheritance, multiple inheritance, all the inheritance is combined together. Okay. So cyclic inheritance, this concept is does not exist, guys. This is the just the concept which is applicable to the a class extending the same class. Class is extending the same feature itself, and class A is extending the class B is extending the class A. So A and B extending the both each other, it is not possible, right? This is the only the concept is exist. Practically, it is not proved. So cyclic inheritance is only the concept, not proven concept so far. Okay, so I'm going to the programming code, writing the inheritance now. Let me go and write inheritance. Okay, so inheritance example dot py. So I will go and write inheritance, guys. Just remember here the rules. Okay, so I will write the class called parent. Okay, so let me write here. Okay. So in this class parent, okay, I'm extending the by default for all the classes. Let me write some text for you. For all the classes, okay, who is the parent? For all the classes, who is the parent, guys? So the parent of, for all the classes, the parent is, okay, the parent is, parent name is object. Okay, so we can use the parent is the object name. So, and also like who is the I mean, this is the same, the object we actually define into the lower cases. This is a class, guys, and we can define it. If you're not defined by default, Python consider it is an object. Okay, now I'm going to write a constructor here. It's a parent constructor. You can write here init, and we can mention here it's a self and the put colon, the print of we can say that this is the parent constructor. So CONS we can write here, right? And now I'm going to use the one more class that is called class child, and this child. So when I say that this child, how this parent can be interlinked with this child, how this can be, we can make a relationship. there is something called inheritance. So if you say that inheritance, so we have, I'm going to write your inheritance. When I can say it is an inheritance, so you have to open the parentheses here, and inside that you can give the who is the parent class name. So parent is the class name. So I'm just giving, this is called inheritance. So in the sense, the class child is extending the behavior of the parent. So this is called the inheritance. If you're not using the parent class here, this is something we can call it as a there is no any relationship between this. Basically, there is no any relationship between this data. So what we need to do, right, we need to provide the parent here, then we can say this is a child. And now here I will create the constructor, simply copy paste. Why we need to write again? So here I will say that this is the child class constructor. Okay, so parent class constructor and child class constructor. So what I will do, right, I will create now an object for this parent and child, and we'll see. Now what I will do, right, I will take this p is equal to the parent, and this is the p dot, and I will access the see here there is no any methods, we don't need to access separately. This is the p is enough. Now I'll create this p is done, right? Now I'm going to execute this code. You'll see automatically there is a parent constructor. So instead of this parent constructor, I will do now c is equal to child. Now this is separately I'm accessing, guys. Let me tell you that the main thing also. So but what is the significance of this parent and child when you're using this one? So if I want to access the parent information inside the child, I can use this, I can create an object for the child, I can access it. So for example, there is a method here. So we can use the method name and show, okay, or else it is a p method. So p method, it's a parent method. There I will write the self keyword, and you put the print statement, and you say that this is a parent instance method. Okay, I'm writing it here. So parent instance method. In similar fashion, I will write the child method here inside this. Let me write child method. Okay, so instead of the C method, I will, instead of P method, I will say that's C method. I will put here it is a child instance method. Both are. So if I want to access this parent P method, this method, I don't need to create a parent object. I can also access the child by using the child object. So this method, this method, this parent method, I can access by using the child object. So parent method can be accessed by uh, child object reference because of inheritance, right? So this is the what the statement is. So what I will do, right, guys, I will use the now the p is equal, I mean c child I'm creating now, child 1 is equal to child. So I'm creating a constructor here. So by using this child 1 dot, I can access the parent information, guys, this p method. So I'm going to access this p method. So now you can see. So because of constructor, because of inheritance, because of inheritance, I can able to access the parent class. So this p method generally can't be accessed by using the child if you're not using this parenthesis of parent. This is an inheritance. With inheritance only, I can able to access this p method. Okay, so p method is an instance method which is there in this parent class, and I can access by using the child when you put the inheritance concept. Okay, now I'm going to execute this code. Let me show you that what is an output, and you will see this is the parent instance method. And using this child one also, I can access the child method itself. So you can look at this is a child method. That something is, you can call it as the c method. So we can access here also. Now I'm going to execute this code. You'll get the output is this is a child instance method. So parent instance method, child instance method, we can access so like this, right? So that's where this is works, guys. Basically, this is a simple example I'm giving. There is one parent, one child. So we'll go with another example. We'll explore the multiple parents and multiple childs, how it works. So I'm now going to explain the multi level, okay, multi-level inheritance. So we'll see now with the different cases now. Dot py. So I will create now two parents here and two childs, are like one parent and two childs. So class, and here it is the parent one, and we can say that, and this is done, and we'll put this pass, and okay, and class, okay, and I'm taking these classes with the different classes here. The class parent one we are done, and class parent two, and class parent three. Parent three is not required here. I will take the different childs, and multiple inheritance. I will talk about the two different parents. Okay, so here the parent one, child two, or we can use only one parent. So one parent with the two childs. So sorry, this one. See, I always follow the naming conventions. When you're writing the class, you can always go for the uppercase letters when you're writing the class name. So this is what the child's, right? But there is no any relationship between this parent, I mean, this class to this class, and there is no any relationship between these classes. So what we can do, right? We can go and create relationships. So what I will do, right? I will use the parent here. Again, I will also use the parent. So the parent is only one parent, but I'm giving an access to the two different childs when I can access this parent information. So what I will do, right? I'm going to create the parent method here. Just we can mention it here, self keyword, and put here the print statement, and we can say that this is a parent method. Okay, and this parent method, and this child also I can write the similar way that, okay, same code you can copy paste here. Why we need to waste the time? So we'll keep it here similar fashion, and instead of this parent method I will say that this is the child method, and this is also will say that child method, right? This is the child method one, this is the child method two, as simple as. And again you will change this one child one, and yes, this is also I will say that child two. Okay, something like this. So one parent with multiple childs, guys. Yeah. Okay. So now what I'm going to do, right? I want to access this parent information from the multiple childs object creations. We can do it. So let me show you. This is C1 is equal to, and we can create an object for the child one. This is one scenario, and C2 is equal to, can create an object for the child two. This is another scenario. Okay, and we can access this one by the C1 dot and child method one, and also we can access the C1 dot and parent method. You can see that's how I'm doing it. And similarly, we can take the C2 dot and child to child method 2. Similar like this, we can access this one. And so, and the child 2 method and C2 dot, and we can say parent 2 method. So different methods I can access here. So C1 is equal to child 1, C2 is equal to child 2, C1 is equal to child method 1, parent method, and like that I can access. So with the two childs, these two childs, by using these two child objects, I can access the parent object information. Now I'm able to see it. Now I'm going to execute this code, and we can see this output. I'm able to see it. So first one is the child one information, that is the child one method and parent method, child two method and parent two. So what I'm going to explain here, basically one parent with the two childs. This is called the multiple. It's not only two childs, guys. You can also take the one more parent. Okay, you can take here one more parent. Here I will say that child three, which is the parent of child one. Can I change this one little complicated like this? You can see a little different here. Okay, so you can say that parent and child one, parent of this one, child two parent, but this time I have changed this one child three, not the parent. I'm using the child one is the parent. So this is also, we can try and execute the code. You can say that this is a child three. Now this child three, I'm going to create now. So let me go and create this C3 dot C3 is equal to child 3, and we are creating an object for this C3 dot, and we can also access the parent method. So I'm able to access it, right? If I go and execute this code, I can also get this one. So what I mean to say that, so your child 3 is actually accessing the child 1. This child 1 again is the parent of this one. So I can able to get the parent information from this references. but we'll go with another examples. I will give more clarity how these relationships works. Okay. Okay, I'm reading your comments, guys. Sorry for that. I am not reading your comments so forth. Please explain more details about the class method versus the static method. It's a very simple, guys. Class method mainly we can use it for defining the some fixed data. Example, I will tell you. Static information means the data which is can't be changed frequently. Okay, bank name we don't change. Bank when it is established we don't change. Something which is the fixed information or fixed data, that is we always keep it into the class, which is a very common thing. The static method means it is a utility method. If you want to define any logic, if you want to work on to those logics, we'll go for the static method. Static method is like a auxiliary method. It is going to be useful when you are working on static method. A simple way. Okay, static method is nothing but you are writing some logic only, like calculating the compound interest, or like something you are calculating the some logic you are putting there. That time only we can use the static method. So class method is something which is you are working on the static variable, I mean the sense of fixed variables or fixed data, which is very common. But use cases I will take in upcoming sessions. Maybe when we are connecting in the evening sessions, we'll work on it. Okay, we can ask these questions, I will explain you. What is the purpose of the inner and outer classes? So inner, see, the class, inside the class we can say inner class. See, class can contains the properties, methods, constructors, docstring, and the methods, various methods also there. At the same time, inside the class, when you say class, inside the class itself is also called it as the a member for that class. So what is the purpose in the, if you ask me, if you want object creation to be done in the inside the class, then we can go for the inner classes. It is very rarely we use, but there is a purpose. When you want to define the scope of the class only within that class, it should not be accessed the outside of the class, then we can go for this one. Okay, inner classes. So moving to the next one, guys, multi-level inheritance is done. Now I want to try for the multiple inheritance. Okay. So before that, someone please confirm on the chart. Do you want me to proceed, or like do you need some time to refresh the content? I'm okay to continue, but please someone confirm on the chat box. Is that okay to me continue? I'm looking at your chat box, guys. Can you please someone confirm? Is that okay to be continued? I'm actually waiting for your response in the chat box. I don't know. Okay, thank you so much for confirmation. I am continuing now. Okay, I'm reading your message. So there is a little delay. Okay. So now I'm going with the concept called the multiple inheritance. Let's see this how it works basically, right? What I will say that let me create the multiple inheritance, multiple underscore inheritance dot py. Okay. So in this, I will take the two parents with the same child, and we'll see that how it works now. So what I will do, right, the class, and there is a parent. Inside this parent, I will use the multiple, okay, different parents here. Like, let's take the parent one and put the colon, the pass, and pass, okay, class. This is the parent two. Put the pass, class, child. Okay, put the something called pass. Okay, this is how. Now what I'm going to do, right, guys? This child, I want to implement the multiple inheritance. So need implementing the multiple inheritance. Implement, or we can say multiple inheritance here. Multiple inheritance. Okay. This multiple inheritance means there is a rule. Okay, we have to give there is something called parent one and parent two. So I will say this is the parent one comma and parent two. So there is a parent one comma and parent two. This class is the child class. This child class is accessing the two parents here. So let me go and write here constructor, say that what I can say that init. So init method, and inside this init method, and we can write some text. So print of this is a child class. Okay, child class constructor. You can define it like this. And parent to constructor, I will write def and init and underscore underscore self, and we can keep your something like a print of parent to constructor. Okay, parent to constructor. And similarly, I'm going to copy paste the same code. So let me copy paste here the same code. This is the parent one constructor. So basically inheritance is actually achieved using the parent one and parent two, right? So this is a parent one and parent two is there, but I can interchange this one. First I can call the parent two, and after that I can call the parent one also. But anyway, I'm going to create an object here. Okay, so say that child object is equal to, then we can use the child of this one, and child object dot. Okay, then we don't need to call anything, guys. It is very simple. Okay, here I'm using the constructor. Now I'm executing this code is very simple. So we got the child class constructor. What is the child class constructor? This one. So, but I'm not able to get this parent one and parent two constructors, right? Because you are not using the super method. I will explain you that when you use the super method, for example, if you use the super and this one dot underscore underscore init underscore underscore and use this one, and especially when you use the self keyword, and when you use this one, if I go and execute this code, okay, but this is expecting the one position of arguments, but two are given. Let me leave it, no problem. I'm going to execute this code. We'll get the parent one constructor. So if you want even parent class constructor data to be printed, then we can use the super keyword. Super is the method dot init, but you are given the first class is called the parent one. That is the reason we are getting the parent one information here. Okay, if I interchange this data, like first one is the parent two, next one is the parent one. If I go and execute this code, you'll get the first one is the parent two, next one is the child class constructor. So what is the basically here, right? I using the parent one is one class, and inside that there is a constructor. Parent two, there is a constructor, and child, there is a constructor. Without using this line number 15, I am able to print the output of only the child class constructor. If I want parent class constructor information, I need to follow this syntax. Super is nothing but a keyword which can be accessed the immediate parent class information. What is the immediate parent class information here? As for this multiple inheritance, immediate class information is the parent 2 only. So that is the reason I'm able to access this data. So parent 2 means, so I can access only parent 2. If I give parent 1, I can access the parent 1. Can I have the one more parent here? Yes, we can create one more parent. It is like parent 3. It is not like only, there is no unlimited parents you can create it here, but only one child. So I will go and use this one now, the parent 3. Okay, now if you look at, if you think because previous slides I explained about something called method resolution ordering. So what is the method resolution ordering? I will explain you. You can go to this print statement, and you can use this child object dot mro, sorry, class name, it's not object. You can use the child class dot mro. So mro is nothing but method resolution ordering. So this will decide that which class to be called first, which class should be called the next, which will be decided like this with MRO principle. Now I'm going to execute this code, guys. You can see first by default it will call the child class, okay, then parent2 because you are giving here parent2. Next one is the parent1, next one is the parent3, and the last one is the object. So what I mean to say that inheritance, multiple inheritance works in such a way that, okay, let me take some, okay. Okay, so let me draw some lines here that you will hopefully understand. So this is the first, this is the second one we are actually working on it. Why this is, okay. So this is the child class first initially called. Next one is the parent2. Next one is the parent1. Next one is the parent3. And finally, you are seeing the object class. So you can see here, it is also calling the same thing. First one is the child. Next one is the parent. And after the parent, it is moving to the parent1. After the parent1, it is calling the parent3. And finally, object. So what I mean to say that here, so it depends on that. You right now you are using the child class. This child class is having the parent2 comma parent1 comma parent3 like this. So there are multiple parents we have it basically, right? So if I change this text, right, for example, if I go, let me tell you. So instead of parent2, if I access the parent3 and here it is the parent2 or like parent1, we can keep and you can change this one. If I go and execute this code, guys, no problem. First you will print the child class. Next one is the parent3. Next one is the parent1. So same order is following it here. So first it will print the child class, then order is the same. So MRO is like, see, if you are not using the MRO, what will happen, right? This child will be confused which parent data I need to access. So that is the reason MRO is there. MRO stands for the method resolution ordering. Okay. So like that I can access by using this. This is a multiple inheritance. This is the concept of, but I'm not going in the deeper, guys. We'll take one more session in future. We will talk very deeper concepts in MRO because this is a first session only. If I go deeper, you'll get confused because with the MRO and super keywords, there are a lot of combinations we can work on it, but I'm not going through that in the deeper syllabus, but we can talk later in the future about this. Okay, this is about the multiple inheritance. Okay, but I just giving the idea only. But the super, like if I want to access the parent class constructor or like parent class methods, I can use the super keyword. So let me talk about the super example. You will understand in different way here. So super method example, super method ex dot py. So I'm creating a separate data here. So class and the parent, and we can say that leave it as it is. I'm demonstrating about the super here. So def underscore init underscore, and you can put the self, put the colon, and you can use the print statement. And inside that, this is the super class constructor. Okay, and same like I will take the parent here. So for a child, here I will change this one to the child, and here also I will change this name to the child. Okay, now inside this I will take the one instance method, say that mm, parent method. Okay, just to make sure that you're following the same thing, and colon, and inside this print statement you can put the print statement. Yes, I'm answering your question. MRO to know the order of the execution of the classes. Otherwise, it will confuse, guys. Okay, I'm reading your comment now. I answered that. So if you are not following the MRO, your child class will confuse who is my parent. So which parent I need to access. So that's where this is actually there. Okay. Now moving to this print statement, guys. Here also I will write. Parent method. So I'm writing the parent method here. In same parent method, I will take this instance method here, and this is the instance method. instance method. So this is the again instance method, something like this. Superclass, parent method, child class, again instance method. So what I will do, right? I will tell you why I'm writing this one. This is instead of instance. So I will use the child class now, COBJ, child object and child, and this is how it is there. Now if I go and execute this code, I will see only, I can access only the parent information, child information only, because I am not given the any relationship, this parent and child. So let me give the relationship here, child and parent, go and execute this code and you will get this is the child class constructor, fine. But I want to access the this constructor, so parent class constructor information. So it's very simple. Already I mentioned in the previous example, super and dot underscore underscore init underscore underscore. So like this, you can define it. This is a method. This is enough. So if I go and execute this code, guys, I'll get the super class constructor and also child class constructor. So both the class constructors, I can able to see it here, right? So that's where like this can be used. This is a super class constructor. This is a child class constructor. But my problem is now I want to access the parent method also. So is it possible? So now what I will do, right? The COOBJ equal to and COOBJ dot child method. Okay, so now if I go and execute this code, I'll get the output of the child method. But now I want to access the parent method. This parent method also I want to access. So without calling this one, by using the child method only, is it possible? It is possible by using the super keyword. So we can use a super keyword dot and give this parent method and call this parent method and just simple like this. Okay, I'm not directly calling this parent method by using the child object. I am calling the child method only. From there, I am able to call the parent method. So what I will do, right, I'm going to execute this code. You can see that parent method is also got displayed. So let me show you again. So what I am trying to do it, guys, I'm actually using the child object only. I'm using the child object only. I'm not created the parent. You can see what is the magic of this code in the sense, guys. Here I am not at all using the any parent object. So this parent, I'm not at all created any object. I'm just using the child object only, but I'm able to call the constructor. I'm able to call the parent class method also. That is the power of the super. Super is the keyword can be used to call the parent class constructor and parent class instance method when you are following the inheritance concepts. If there is no inheritance, I can't able to access this data. So, but for your information, you can call the constructor from this constructor. You can call the instance method from the instance methods. This is the importance of the super. So I'm not using the any parent object here. I'm using the child object only. Why I'm repeatedly saying this one? This is you have to remember here. There is no anything about the parent. Okay, so that's where the self can be used. But there is so many other advantages also there, like with the different use cases that we can see in the advanced OOPS concepts in future sessions. I'll talk more about this advanced features, okay, in upcoming sessions. This is about the super method. Okay, so moving on to the next one. Okay, so there is abstract class and polymorphism is there, but let's talk about there is something called method overloading and method overriding. Okay, so I'm going to talk about the method overloading and method overriding. So let me create now. There is something called method overloading. Okay, dot py. So here I need to make sure that there is an important point you should remember. Here now I'm talking about the polymorphism. So polymorphism is actually like, so the polymorphism basically we are defining into the multiple forms. So in polymorphism, we use the two important concepts. called the method overloading. So method overloading and method overriding. Okay, so these are the overriding. So spelling may be wrong, but excuse me for that spellings. But I am just telling you this method overriding, method overloading. So method overloading happens. Basically, this happens only within the class. This is within the class. So this method overriding happens in hierarchy of the classes. Okay, in inheritance basically. Okay, in inheritance are multiple classes, or you can say that multiple classes. Okay, so this is something you should remember. So method of overloading is happens within the class always, and this method of overriding happens in the in inheritance, like it is nothing but super and child concept. Okay, something is like this. Now what I'm going to do, right, this method of overloading is not possible. I mean to say that not recommended or not achieved basically. So not possible, we can say not possible in Python. So this is possible. This is possible in Python. Okay. So when it comes to the overload, see, polymorphism talks about the three important concepts. So overloading and so another concept is the overriding. Okay. So these are the two concepts. So overloading we can talk with respect to the constructor, and also we can talk, see, constructors also will come here. The constructor overloading and method overloading, and the last one is the we can say, I think this is an operator overloading. Yeah. Okay. And overriding is constructor overriding. Okay, this can be possible, and method overriding, this is the out. Okay, so in Python these two are not possible. Okay, so only operator overloading is possible. Operator overloading is possible, right? So I am just giving the right information for you. So okay, operator overloading is possible, but this constructor and method overloading is not possible. So polymorphism is like this, guys: overloading and overriding. Overloading is for the constructors, methods, not possible, and operator overloading is there, it is possible, and overriding is for the constructors and methods, and of course it is possible. Okay, in Python. So only these two are not possible. And I'm talking about method overloading. Method overloading is not possible. Let's go and write programming to understand better way. So class A, and you can define the so method one. I can say that show method. So you can put the self keyword and put the pass, and you can create a def and show method, and again self, and you can write here the pass. Okay, so basically what is this one, right? So this one is something we can call it as overloading. So this is the overloading, same name and all, or like you can give the this one is the name, and you can give here self comma name comma age. Okay, so this is it is not actually possible. Okay, so but how we can achieve it, this a is equal to, or we can say that object is equal to a, and here object dot, I can call this one, right? Okay, I can call this show method. So if you call this show method, the latest one will be called. Let me give print statements here, then you will understand in better way. So in show method, in show method 1, and I'm giving the same print statement here also in show method 2. Let me try this. Now I'm going to execute this code, guys, and you see the output is yeah, because show is expecting some parameters, right? If I'm giving this, see, even if you remove these methods also, we'll try first, then we'll try with the those things. Okay, now I'm trying with this code without parameters. After that we'll try with the parameters. Now I'm executing this code. You can see by default it is printing the second method. So what I mean to say, that method overloading is not possible, because it will take the latest code only. Okay, so what if I'm giving this parameters here, name comma age? I'm pass this name, for example, first name is the John. I'm going to print this output here, but you'll get an exception because this is actually reading the second method. So I will use this John comma and 45, and you can go and execute this code, but still 45 we are giving, and the self comma name comma age, this not it, sorry guys, I did mistake. This should be given in the show method. I'm given in the wrong one. So you can give this show method, this is working. If you remove the 45, if you go and execute this code, you'll get an exception. Okay, so this is something you should remember. So method of overloading is not possible. So next one is method overriding. I am going to do it. Okay, so class A and def, and we can say that show, and we can put the self and colon, the pass, and you can use the class B, and you can access the A. So this is called as a method overriding. Okay, I'm actually creating the same method I am writing inside this class. Okay, so what is the definition of the method overriding? So parameters can be varied, but the name can be given the same, right? We are given the same function name, method name here. So this is how it is there. This is the class. Okay, but this can be possible, guys. You can change the names here. Okay, this can be possible, but we can access by using the A is equal to A, something like this, and B is equal to A also, B is equal to B also, we can create it here. Okay, this can be done. But now if I'm going to give here, for example, the print of say that hello and how are you. Okay, this is one method, and I'll take another method here, hello, and this one is the happy new year. Okay, something like this. I'm creating the two methods here, right? So how to access these methods? A dot, and can I give any method name here? So for parent, I can access this A method A only. So if I go and use this show method, this I can access. B dot show, I can access. This is okay. This is if I go and execute this code, what is happening? This is the uppercase letter B. Okay, I'm going to access this code. I got the output is same, but my point is that how method overriding works. For example, I want to call this show method from the child. Okay, so I'm not going to create in here the A class parent A object here. I'm using the child object only. B is equal to B and B dot show. Which show method is going to be called? Is it a child class or the parent one? If I go and execute this code, I'll get the child one only. But if I'm not created this method in the parent, if I'm not created here, for example, if I'm not created this method in the child, if I go and execute this code, I'll get the parent method. So that is called the overriding. Overriding in the sense, so you are calling the show method. If the show method is present here, assume that, okay? So you can see here, the show method is present in the child class. So you can access the, if it is present in the child class, it access the child class one. If it is present in the parent class, parent can be accessed. Okay, if you are not giving this one. And also one more important thing, guys, I'm giving the name here. Here I'm also giving the name 3, and what I will do, right, and also I'm giving the age. So in this show method, I will pass the name is like only Raja. Okay, so now I'm going to execute this code. You can see I'm getting an exception, missing one required parameter called age. So basically it is calling the child method. So we need to pass here, for example, comma and 66. If I'm giving this age, I'm going to execute this happy new, this message will be printed. Okay, so method overriding, I will take another use case in the upcoming sessions. Okay, in the real-time scenarios. All these concepts we am just going with the basics only, but we can work on with the real-time examples, and that I will plan some other day if you are really interested, and we can work on it. So I'm not going about the operator overloading today. Operator overloading is something is little heavy concepts. I don't know how many of you know about the Dundle methods. So Dundle methods, magic methods in Python, we can start with underscore underscore, and we can say that, so for example, like this, underscore underscore str underscore 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 add underscore underscore. So simple example I will tell you and close this operator overloading. So let me go to this simple one called the operator overloading. This is a simple example I'm giving that, but we can discuss later with big concepts. Okay. So in this operator overloading, you can see, guys, it's very simple. You take this A is equal to 3 and B is equal to 5. Okay. And if I say A plus B, how to print the addition of the two numbers? We can use the A plus B. This is one way only generally you guys think. But Python backend, it uses the Dundle method. It is operator overloading. A dot underscore underscore add, and after that we can pass. So this is also will give the same output, right? So A is equal to 3 and B is equal to 5, and print of A plus B, and A dot underscore underscore add of underscore underscore B will get the same output. So this is actually internally, if you want to achieve the operator overloading, so operator overloading, Python internally uses the Dundle method. Python internally Python uses the Dundle method. Dundle methods internally. So I will talk about this example in upcoming sessions. I don't want to go because this will take another 15-20 minutes of time to explain the operator overloading. We'll go in depth. So what I'm going to do, right? I'm going to stop at this moment. We'll see this abstraction and the duck typing principles. Some of the content which is left over, I will explain you in the next sessions. So I don't know how far you understand these concepts, guys. Let me know by today evening, and I will try to showcase the different examples or different scenarios, or something you think like something is missing. We can discuss in the upcoming sessions. Is that fine? So I'm going to wait for another 5 minutes. I will read your questions. You let me know what are the questions you have it. Okay. Is that okay? This session is understandable, or like it is not understandable? Like what is missing? And please let me know right away. It is good. Immediate feedback is always good. So any feedback, guys? Okay. How is that? I mean to say that is that content is understandable? Okay, so I will try my best next time. We'll go with some more examples, and we'll try to finish it off. So for today, I'm closing this session, but there are a few concepts left over, guys, like abstraction and a little more about the polymorphism, like duck typing principles and encapsulation. But these concepts we can talk in the maybe in the some other day. Okay. Thank you so much for joining the session, and have a nice day. Thank you. Bye bye.